Hello, I'm Preston McCauley and welcome to AI Quick. Today I'm going to be showing you some examples of how to use large language models in unique, fun, and exciting use cases. So sit back, relax, and enjoy. Hello, I'm Preston McCauley and welcome to another episode of AI Quick. So first, before we get started, I'm excited to announce that after about 6 months, I was able to finally publish my book. I'm really excited to share it all with you. Here it is for the first time, Generative AI for Everyone. It's really meant to help you not just understand how to use AI, but the strategy behind building amazing prompts. I have multiple frameworks in here, and there's hundreds of pages of good, detailed examples to really work for any type of field you can possibly imagine. So you can get it over at my bookstore. You can follow the link below, or you can also just go ahead and grab it on Kindle or Apple Books. Now let's get started with our AI Quick episode. All right, so let's get started. So I've been talking a lot about different types of models, and when it comes to multimodal models, there's been a lot of changes recently in the last year with vision models. And of course, notably, we have Ollama Vision 3.2, which is a multimodal model which supports both understanding images as well as text. And so I wanted to push these models to the max, to the limit, right? So what I wanted to build was an application that really can show how this technology can move way beyond chatbots and into whole other areas, and also show you how an average person can use this type of technology to be able to push the boundaries of what we think is possible. Now, I use a lot of different AI systems, from Claude to the latest O3 mini structures and in GPT, as well as working with experimental models like Gemini, thinking models like DeepSeek, etc. And I've learned to build things really, really quick with a lot of these systems. I have a lot of programming knowledge and product management knowledge, and allows me to assimilate all of these different technologies really fast. So what I'm demonstrating here today is highly experimental, but it should give you some ideas of how to kind of bring AI to kind of the next level, and that anybody can really start to experiment with this type of technology. Now, for this example, I'm using Ollama 3.2 Vision, and what I first did is I want to kind of lay out the process. Now, having a background in user experience design, as well as a level of expertise within AI, has really helped me to think about how I problem solve and how I reach solutions, specifically in the realm of innovation. So this first part that I do when I'm looking at a new area is that I apply those research skills and techniques to understand how a particular field works, and how people in that field might work. So I've been doing a lot of work with neuroscience and medical research, and all those different fields, and I have over the past many years. And so I turned towards looking at one particular segment, in this case CT imaging and brain scans. And what I did is I actually took and I went out and I researched how radiologists work, how they're analyzing the different types of CT scans. I looked at the Harvard Medical Journal. I looked at the training manuals for these items, and I also went to a couple other universities that had their knowledge online to help understand, get a rudimentary knowledge behind what we're looking at when we're looking at tissue, soft tissue, the types of tissue, looking at items such as housing field units, and all of these different aspects to help me understand enough to actually approach experimental ideas here. So part of the challenge is trying to find the data, and there's a number of sources out there I was able to finally find after a lot of research to dig these up. Now, much like any process, I follow a lot of scientific methodology when I'm approaching these types of applications, looking at what are the right approaches to use the data, looking at formats, standards, technology that's involved, and really trying to get a good understanding of how the process is working today. And then what I do is I take and I apply AI knowledge across that entire spectrum to understand areas of my own limitations, research zones I should look at, and a number of other areas. So let's get into it. So first and foremost, this is an application that's very experimental. Don't use this to go out and analyze soft brain tissue for full medical analysis. This is just meant to show you how this technology can actually start to be applied in unique ways. And since I'm running this all locally on Ollama, I could also tap into vision models and pictorial models and other ones that would be very, very powerful in this space too. But we have an application here, and it's a multi-part application that I assembled using a combination of multiple techniques. For this, I'm using Streamlit. It's a very quick way to put together a prototype, build out an idea, and kind of test some of the efficacy of it. So with this Streamlit application, what I basically did is I identified a series of brain CT scans, contrast scans, that are in the standard format, which is DICOM. Using Python, what I'm actually doing, and a couple other techniques, I'm converting these into 64-bit base, and then I'm passing them into the model systematically and analyzing them over time. Now, this is the first approach to this, of course, but the other things that I'm doing is I have went through a lot of prompt engineering techniques to refine the prompt, as you see here. So I've added in some systematic approaches, both system instructions as well as standardization method, and I'm just using a Llama 3.2 vision model. Now, you could do a lot more with some fine-tuning or even some reg data approaches, but the whole point here was to kind of see how quickly could I put this together, what elements are working and what elements aren't. So in a matter of moments, I can run through an entire subset of patient data in this experiment. And you can also see how these different prompts are helping to evaluate both the measurements and the techniques. Now, after I had this entire application together, what I wanted to do was reanalyze it. So I used a number of AI systems, GPT, I used Claude, I used a Gemini experimental model as well, to analyze all of the code, but not just the code, but the methodology behind how I'm approaching this, to see how these different AI systems are looking at both my experimental methodology as well as the approach to assimilating these data pieces. Now, while this of course is AI quick, there is a lot going on here, and I'm not going to have time to explain all of it in great detail and depth. However, through these different prompt structures that I've set up, I'm basically setting up baselines using the known metrics that are typically used when radiologists are reading these types of scans, as well as a number of different types of conventions within the prompt structure to ensure standardization. And I'm also using Pillow and a pill library to kind of also identify on the image itself, specifically where the abnormalities might be detected. And I also do 4 things here. One is I try to apply what I consider the persona, if you will, from the clinical perspective. I also have what I would consider the layman's perspective, so that you can understand really what that clinical perspective might potentially mean. And then I do some predictive analysis potentially of what could be going on with this CT scan. As I mentioned, highly speculative. It needs a lot more research, a lot more refinement. But to get this far in such a short amount of time is actually pretty amazing. I want to thank you for joining me today. And if you have other questions, I'm happy to answer them on the comments. Be sure to like, subscribe, all of these different videos. I'll be sharing a whole bunch more to come. And if you haven't picked up a copy of my book yet, Generative AI for Everyone, it's out now on Kindle. It's also out on my bookstore, and I'll have the link below here. And have a great day.